So the good news is I have no new knowledge to impart to you today. There's nothing new that I'm going to teach you. We're really just doing practice and review. And why are we doing practice and review? Because the test is next time. So on Monday, we're going to have a second term test. Because I did this last time, I'm going to do it again because the recording failed. So for those of you at home, we're going to have this test in the regular room at the regular time. So the regular classroom from 3:10 until 5 p.m. So it's an hour and 50 minutes. It's going to consist of the following elements: 8 symbolizations and 4 derivations. 2 of them basic rules, 2 of them derived rules. And just a reminder, in predicate logic, derived rules include all of the derived rules from sentential logic plus quantifier negation and alphabetic variance. So, any questions about that? Yeah? So it'll be the same as last time. There'll be a list of the names of the rules that are included under basic and a list of the rules that are included under derived. Yeah? Okay. Yeah, test 2 is going to look very similar to test 1, except there's no truth table and there's no short answer question. It's just the symbolizations and the derivations. And obviously it's in predicate logic rather than, you got that. You assumed that. Good. Okay, any other questions before we dive in? Okay, good. We'll see you all here. Actually, we'll see many, many more of you here on Monday. Okay. Okay, so I'm just going to do review today. Today, the only thing we're going to do is review our symbolization stuff and do a bunch of examples. That's all we're going to do today. So if you got any questions or anything remains unclear, now's a good time to ask that stuff. We're just refreshing ourselves before the test kind of stuff, okay? Okay, so recall the following. Recall that we've got this 4 types of general sentences, and we've got kind of general formulas for each of them. We've got universal affirmative, you're saying all of something is something. Universal negative, you're saying none of something is something. Particular affirmative, there is at least some things that like this. And particular negative, there is at least one thing that's not like this. So let's just review these. Universal affirmative, so saying everything in this category has this property. So here's a version of it. Every rabbit is swift. And the basic structure of this is you do a universal generalization and you put the category or the thing that's the topic in the antecedent. And then the consequent is the thing that you're saying about that category or topic. And of course you recall, so this is a super simple example. The category is just rabbits, and the things being said about all rabbits is just that they're swift. Of course you recall that this can get more complex. You can have more than one thing in the antecedent. You can have more than one thing in the consequent. So if we say all fuzzy rabbits are swift, we would say in the antecedent we'd have things that are both rabbits and fuzzy. Call all this. Okay? So recall also that we talked about 2 different ways of specifying the topic. We've got at least 2 ways of clarifying what's in the topic. You can add conjuncts to the antecedent, or you can add more conditionals. And just to reiterate, if you're doing the conditionals thing, brackets go to the right. Here's why. Okay. Number 1 is doing it wrong. Number 1 is doing it wrong. Number 2 is doing it right. So number 1, supposing F is a fox, G is well-fed, and H is happy. Number 1 says this really weird thing. If something is a fox and it is well-fed, then that thing is happy. And the second thing says all foxes that are well-fed are happy. So number 2 says of the category of all things that are foxes, so we take that as our largest category, and then we restrict that category even more to those things that are well-fed as well as being foxes, then of those things, they have the property of being happy. So that's what happens. That's the one you want. That's the one that's on the right. We'll put the brackets to the right. The thing on the left is true under weird circumstances. So it's actually really easy to make this thing false, because what makes the antecedent if fx then gx true? How do you make a material conditional true? Well, you make it true by making the antecedent false, right? So anything that's not a fox, my shoes, the planet Venus, the concept of the number 4, all of those things, if we plug those in for x, it makes the antecedent true. And if the antecedent is true, the consequent is false, then the second conditional there comes out as false. So we plug in the planet Venus, and that makes the antecedent true, but is the planet Venus happy? Unclear. Probably not, right? So somehow the happiness or lack thereof of the planet Venus has become relevant to whether this sentence is true or false. That's not what we wanted, right? We wanted, presumably, I don't know, maybe that's the sentence you wanted, but if the sentence I gave you was all foxes that are well-fed are happy, or all well-fed foxes are happy, then the second thing is the way. You want to put the brackets on the right, just to remind you of that. Do you recall this? And does that make sense to you? Just remember to either use conjuncts. So another way to do this would be say, for all x, if fx and gx, then hx. We just don't use a series of conditionals, just use a conjunction to narrow down the topic. Is that good? Okay. This is all today's going to be. It's just going to be saying things that I said before, but again and more. Maybe louder. Does that help? It doesn't matter. All right. Yeah, okay. So, and recall this as well. So this is again with the universal affirmative. To expand the category, we use disjunctions. To narrow it, we use conjunctions. So the first sentence, if I want to say foxes and goats are happy, where F is a fox and G is a goat and H is happy, the first one says anything that is both a fox and a goat is happy. There's not many things like that. There's not many fox-goat hybrids. That's not what there's no object that satisfies both F and G, but there's lots of objects that satisfy F or G. There are both foxes and goats. So to expand the topic, we use disjunctions, and to narrow it, we use conjunctions. Okay. Familiar? Yeah? Okay. And recall this thing as well. So I'll just throw this thing in to remind you. This stuff about relative clauses. This trips a bunch of people up, so it's worth doing. So there's a big difference between these two sentences. The difference is in the commas. The first sentence has 2 commas in it, which carve out a relative clause. And they carve it out as a non-restrictive relative clause. So the first sentence says 2 things. Movies are exciting, and movies sell a lot of tickets. It's 2 separate claims. The first one is about only those movies which are exciting. Only exciting movies, this sentence claims, sell a lot of tickets. Or at least it's only making claims about movies which are both exciting and movies. Yeah? So the key is the commas. Look for the commas. If you see a clause being carved out by 2 commas, then it's a non-restrictive relative clause. It's not restricting it to just exciting movies. It's saying movies are exciting and movies sell a lot of tickets. Versus those things which both satisfy the predicate movie and satisfy the predicate exciting have this property of selling a lot of tickets. Okay with that? Okay. Okay, so enough for universal positive, so let's do universal negative. Nothing in the category has the property. Here's 2 ways to symbolize that. You could say, so we've still got the same topic and then claim structure. but we're saying of everything in this topic, everything in this category, they all fail to have this property. And an exactly equivalent way of saying this is there does not exist anything that has the property of being in the topic and having the thing we're saying that it doesn't have. Okay? So those are both perfectly valid, equally good ways of symbolizing the same thing, the universal negative. Either for everything that is in this topic, it doesn't have the property, or there doesn't exist anything which is in this topic and has the property. Keep this distinct in your mind from saying not everything in the category has the property, right? That's different than saying all movies fail to be educational is one claim. You're claiming that there doesn't exist any educational movies, versus not all movies are educational. One of those is true and one of those is false, right? I take it that there do exist movies that are educational, right? So it's not the case that you can make this universal negative. Of all of the movies, none of them have educational value. But it is true that you can say there exist movies that don't have educational value, right? So keep those distinct in your mind. Okay, happy with that? Don't worry, there's not too much of this review. We'll get into examples soon. Particular affirmative, we're doing this with an existential. Some members of this category have this property. Some dogs are lazy. It's just an existential where you apply both things to the topic, right? So you say there exists something that is in this category and has this property. It should be, I feel like this is the easiest one to symbolize. Yeah? Okay with that? Good. And the particular negative, it's just applying a negation to the claim. It's just saying there exist at least some things in this category that don't have this property. So this would be there exist movies without educational value. There exist movies that don't educate. So there are some things that have the property of being a movie and don't have the property of being educational. Something like that. Okay, so those are our 4 categories. There are 4 types of sentences, of general sentences. There are also particular sentences that don't get a quantifier, of course. So we say, Beth is not lazy. You don't need a quantifier for that. You just stick in the name. I take it that we don't need to review that. Yeah? Okay. Good. If there's no questions, then we'll just do examples for the rest of the class. Right. Okay. Here we go. So, also recall this stuff about number. Yeah? This was annoying, wasn't it? That's why I'm making you do it. Yeah. Okay. So, exactly 2 of James, Tara, and Sam went to class. Exactly 2 of was one of the more annoying versions of the number problem. Okay, so here, this is not a general sentence. We don't need a quantifier. We're going to symbolize James went to class as CJ, Tara as CT, and Sam as CS. Okay? And now it's just a matter of, suppose that you've utterly forgotten how to do this numbers stuff. Remember that the default strategy should be just enumerate the cases that satisfy this. Just what are the cases that we need to capture to make sure that we've got at least 2 of them go to class? Sorry, exactly 2. Well, in any case where exactly 2 went to class, that means that 2 of them did and 1 of them didn't, right? So we'll just describe those cases and put disjunctions between them. So CJ and CT and not CS. There. Now exactly 2 of them went to class. That could be the case. Or CJ and not CT and CS. Or, let's do it down here, not CJ and CT and CS. This is one of those ones where there's not much of an abbreviation to be had, right? There's not much of a compression to be had. You just describe all of the cases. Yeah? And recall again, this is one of those weird symbolizations where the structure of the sentence really has very little to do with the logical structure of the symbolization. It doesn't say or 3 times, or there's not 2 ors in this sentence. There's an and, but there's like a bunch of ands in this. So just keep in mind that it's not always going to be the case that the apparent structure of the sentence is reflected in the logical structure of the symbolization. Questions about this? Everybody happy? Not happy, you're surviving your week. Okay, let's do another. It's cruel to ask undergraduate classes if they're happy this late in the semester. Just get through it. All right. Okay, here's another number one. At most, 2 of James, Tara, and Sam went to class. At most. Okay, this is the one we can do compressed. So, at most 2. Yeah. The naming conventions. Oh, yes. Sorry. Yes. I violated the naming conventions. He's quite right. A to H, so this shouldn't be T. That's a variable letter. That's right. Thank you. A, B, C, D, F, G, H, I, J, shouldn't be J. All right. So we'll call this A and B and C. Thank you for reminding me that. Yeah? Well, so in predicate logic, or sorry, in sentential logic, on test 1, I've just used whatever letters. I think on this one it would be better if I was a bit more careful, because now it's starting to matter. So in your derivations, it's starting to matter whether you're using a name letter or a variable letter. So I'm going to be more careful on the test about using just name letters for names, just variable letters for variables. Yeah. So I've been sloppy here today, but I'll be more careful on the test. You're not going to have dozens of names to sort out, and you'll pick your own variables. So I take it won't be too onerous. Yeah. Other questions? Okay. Okay, so let's do at most 2. So now we got this time CA and CB and CC. Okay. So at most 2 rules out really only one scenario, right? It really only rules out the scenario where they all show up. At most 2 is compatible with 2 of them showing up, or 1 of them showing up, or none of them showing up. It only rules out the case where all 3 of them show up. So really, all we have to do is say, describe the case where all 3 of them show up, CA and CB and CC, and then go ahead and negate it. We're saying it's not the case that, and we can kind of do just exactly equivalently, we can just do a De Morgan's on this thing. We could say not CA or not CB or not CC. Yeah? Either one of those would do it. And you can also do it, there are more labor-intensive, longer ways of symbolizing this as well. You could just spell out every single case. So like the case where 1 of them shows up and not the other 2, or 2 of them show up and not the other one. It's a lot of cases to go through, but again, so long as you rule out the relevant cases and rule in the relevant cases, it's fine. Okay? You okay with this? Okay. If there's no questions, so we'll do another. Yeah? Do you have to? No. So if you just done, if you left this out entirely and only did the first one, that would be fine. So if you did this, yeah, that's full marks. Yeah. just wanted to show you, it just occurred to me that there's a second easy way of representing this, so yeah. Okay. Okay, that's enough number stuff. Let's not do any more number stuff. That's annoying. Ah, here we go. Here we go. Let's see here. Oh, no. Good. Okay. Either all spotted giraffes are clever, or all clever giraffes are spotted. Okay, so now we're going to start remembering some of our symbolization skills from back in the sentential logic days. The goal is don't try to figure it out all at once. Break the sentence down. The first step is always to try to identify the main operator or the main connective. What's the main connective of this sentence? Or. Yeah, it's either or. It's either this thing or this thing. Okay, so going to be an or in the middle of the sentence. And now once we figured out the main thing, we can start thinking about the parts so that we don't overwhelm ourselves by trying to deal with it all at once. Fortunately, these parts seem fairly manageable, right? You say, all spotted giraffes are clever. So it's a universal, right? All is it's a pretty dead giveaway that we're going to deal with the universal here. So for all x, now what's the topic? And when you've got a universal affirmative like this, we ask ourselves, what's the topic and what's being said about that topic? So the topic of all spotted giraffes is spotted giraffes. Saying if something is a giraffe and it's spotted, then it's clever. I've drawn these brackets badly, but yeah? And alternately, we could have done if something is a giraffe, then if it's spotted, then it's clever. Making sure to keep the brackets on the right, of course. You don't want a conditional in the antecedent. That would have been just as good. Okay? And now let's do all clever giraffes are spotted. Same predicates, but a different thing is the topic here, right? Now the topic is clever giraffes. So I'll use y this time just to keep it clear for myself. So if something is a giraffe, gy, and it's clever, cy, then it is spotted, dy. Great. Yeah? You do not have to change it to y. You do not have to change it to y. So if you had done x's all there, that would have been fine because the scope of the first quantifier ends with this bracket here. So this is the scope of this quantifier, and, sorry, that's the scope of this quantifier, that's the scope of this quantifier. By the time you get to the second quantifier, it's a whole new variable. If you put x in again, there's no reason to think it's the same x as before, because the scope of the first quantifier is already ended. Huh? I mean, I like putting in a new quantifier because, partly because of how hectic it's going to get when we do multiplace. So after the test, we're going to start doing multiplace derivation or symbolizations and derivations, and then we'll have several variables in play within the scope of the same quantifier, and it gets a bit, yeah, you'll probably want to use fresh variables there. So just, I find it easier to think about, but you don't, strictly speaking, need to. I think Logic 2010 doesn't do, like Logic 2010 automatically generates the x's for the second variable, so it's clearly, if Logic 2010 thinks it's okay, it's obviously fine. Okay, any other questions about this? Yeah. 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 So the The question is this okay too? If dx, then if gx, then cx. And yes, that would have been fine too. So the way that you can assure yourself that that would have been fine is the logical equivalence of, so if you have dx and gx, that's logically equivalent to gx and dx, right? You can picture in your head the derivation steps where you simplify one of those apart and then re-adjoin them into the other one. So if you can derive one from the other, that means they are going to be like logically equivalent, or at least, yeah. So if you could imagine the derivation steps that would take you from one to the other, it's a pretty good bet that they're logically equivalent. Okay? Okay, let's do another. Right. No one ruining the fun is a necessary condition for every person to get what they want. Remember necessary and sufficient conditions? That's another thing you should remember. And I cannot remember whether necessary condition goes in the antecedent or in the consequent. Never. It's the same thing with bi-monthly. I've heard does bi-monthly happen twice a month or once every 2 months? I cannot remember, no matter how many times I hear it. It just does not stick in my head. So every time I have to deal with symbolizing necessary and sufficient conditions, I have to go through the following steps. I have to say, okay, so oxygen is a necessary condition for fire. That's right? Oxygen is a necessary condition for fire. No oxygen, no fire. Yeah? Okay. But of course, fire is not a necessary condition for oxygen. We would all be in deep, deep trouble if that was true, because we are all breathing oxygen, and fortunately, we're not on fire. Okay, so how do we symbolize this? If I say, if O, then F, that means what? The presence of oxygen guarantees the presence of fire, and therefore we're all burning to death right now? That's not right. You can tell that's not right. That means it must be the other way around. It must be that fire, if fire, then oxygen. I have to do this every time. Okay, so oxygen as a necessary condition for fire gets symbolized as if F, then O. Okay, so now let's do that to the parts of this sentence. We'll get it the right way around. So, no one ruining the fun is a necessary condition for every person getting what they want. Okay, so this is the oxygen is a necessary condition. This is our oxygen, and then this is our fire, right? Oxygen is a necessary condition for fire. No one ruining the fun is the necessary condition for the other thing. That means that we need, if this thing, if the second thing, then the first thing, right? Okay, so every person getting what they want. So that's a universal, so for all x, if they're a person, then they get what they want. And we're going to say, if this whole thing, then no one ruining the fun. Right? Okay, so how do we symbolize no one ruins the fun? Totally valid. There's a variety of ways you can do this. It sounds to me like a negative universal, which we said there's 2 ways to symbolize. So let's do just the version of this that seems most natural to me right now is there doesn't exist anything such that they're a person and sorry, they ruin the fun and they're a person. So sorry, NY and FY. It doesn't matter. The order doesn't matter. But so there doesn't exist anything that's a person and that thing ruins the fun. Yeah. That's right. Yeah. So if I'd done this all with x's, that would have been fine too. Yeah. Once again, because of the scope of these quantifiers. Yeah?
So if the residential is a part of the universal, why has to be subtracted?
If it's part of the universal.
If it's inside the scope of the universal.
Right, right. So that would look like this. But actually, no, that would still be fine. And why is it fine? It's fine because the innermost quantifier takes precedence in binding, right? It's the innermost quantifier that binds the variable, not the outermost one. Yeah? I recommend you don't do that because I think that's harder and more confusing to read. I mean, I think this makes more sense, right? I think this is intuitively clearer and more straightforward, but there's nothing logically wrong with either of the two things that I just showed you. Yeah? Further questions about this one? Yeah? So you could say for all y, you can't, I think you can't just negate the bracket. Like, I don't think you want to do that. No, actually, that's okay. That's okay. This says for all y, it's not the case that it has both of these properties. It's not the case that it's both a person and ruining the fun. That's okay. I think the way I showed you before was like this. For all y, if they're a person, then they don't ruin the fun. That's how I would, I mean, that's my, again, my default, but. Yeah? All right. Good, we're getting through these. Let's do another. Let's not do that one. All right. Okay. Among colleges and universities, those that have libraries are well equipped unless they don't fund them. Okay. So a complex topic here. Complex topic and a complex thing being said about the topic. So certainly we're going to narrow it down to colleges and universities. Let's start with a universal. So we're saying something about all colleges and universities, right? Right? Okay. And recall what we said before. So this will trip you up if you don't remember this, because there's an and in there. And you're used to, anytime you see an and, representing that with a conjunction. But what happens if I do this as the antecedent? If I say CX and IX, now I'm saying that something is both a college and a university. And somebody should tell OCAD that you can't be both a college and a university. Sorry, I don't want to punch down at OCAD, but what the sentence means, what we're trying to do is expand. When we say colleges, amongst colleges and universities, what we're trying to do is expand the topic to things that are either a college or a university. Certainly the sentence is not talking about only those things that are both colleges and universities. You're saying if anything is a college or if anything is a university, then those that have libraries, so if it has a library, then they are well equipped unless they don't fund them. What was unless? Recall this, so dredge this up from your old sentential logic days. I know it was a long time ago. Unless is an or, right? It's one of the less intuitive ones. It's one of the ones that I kind of, we had to shoehorn logic, we had to shoehorn language into the confines of logic. But as a kind of convention, we accepted that unless should be symbolized as an or. So we know it's something or something. They are well equipped, so EX, or they are not well funded, so not FX. Make sure we get the right number of brackets here. A lot of brackets. You need a lot of brackets. I don't know if I gave you the right number of brackets here. Here's how I'm going to try to figure it out. Here's my trick. You count up the number of brackets going in one direction and the number of brackets going in the other, and if it's the same number, probably you're okay. So, 1, 2, well, count the ones, 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh no, I've done something wrong. I've definitely done something wrong. All right, so this is the one binding going to this. This is okay. Yeah, okay, that's right, that's right. I feel like half the things I teach you in this class are how to cope with being kind of fuzzy-headed, which is what my life is like. Like, you don't need, most of the tips that I give you, you don't, if you're just like, have a sparkling, clear mind with excellent working memory, I'm not very much good to you, but I'm speaking to those of you who are like me, so. Okay, questions about this? Yeah?
Could you put LX on the left and conjugate it?
You bet, you bet. So we could do the following. We could say, for all x, if CX or IX. And the only thing we have to be careful with here is making sure that there's a bracket between the and the or. So then EX or not FX. Okay, need one more bracket here and one there. Okay, so yeah, I just want to warn you, don't mix ands and ors. You recall that that comes up with a not a well-formed sentence. So if I said just this, CX or IX and LX, recall that that's not a well-formed sentence because we don't have neither, it's not that one takes precedence over the other, and these are two very different sentences. So this thing is a very different sentence than this thing. Yeah, do you recall this from when we introduced the ands and the ors? So just make sure you get the brackets in there, but this is a perfectly good way of having this kind of quite complex topic. We're saying if anything is a college or a university and it's got a library, then this thing holds. How's that? Questions? Okay, let's do another. All right. One with a name in there. And it's a name that's not a variable letter. Success. Great. So, unless there's a coffee shop open, Amy will be sad and no work will be done. Okay. Right, so this is an unless, so the unless something then something, so the major connective is going to be an or, so disjunction, right? Okay, so something or something, unless there is a coffee shop open. Okay, now that's not a universal, right? We're not saying all coffee shops in the universe are open. We're saying unless there exists at least one thing that is a coffee shop that is open, right? So symbolize this as an existential. And AX. So either there's an object with the properties of being a coffee shop and being open, or Amy will be sad and no work will be done. Okay. So Amy is sad, is just EA. We don't need a quantifier there. We're saying a specific object has the property E. And no work will be done. So H is work and D will be done. We could say there does not exist anything such that it is work and it will be done. It's a strong claim. It's a strong claim. Saying nothing in the universe that is work will be done. That does sound like the kind of thing that the sentence is saying. How's that? Any worries about this one? Okay, let's do another. Okay. Bill, who isn't picky, ate some greasy chicken for lunch. Okay. Notice the double commas, the two commas there, picking out that Bill isn't picky. So we're not saying of all of the Bills who aren't picky. We're making two claims. We're saying Bill isn't picky, so that's a pretty easy one. BB. And Billy ate some greasy chicken for lunch. So the topic of that second sentence, the second conjunct, is kind of not Billy. It's kind of greasy chicken, right? We're saying there exists something, at least something, such that it's chicken, and it's greasy, and Bill ate it for lunch. When we get to multi-place predicate logic, we'll be able to say things like, so adding was eaten by Billy for lunch is a weird predicate, right? When we get to multi-place, we'll be able to say A was eaten by B, so we might be able to say X was eaten by Billy. Just don't worry about that for now. Just to signal that we'll have a more sensible way of symbolizing this soon. How's that? Yeah?
I think the first half should be negated because this says
Oh, you are absolutely correct. You are absolutely correct. Sorry about that. Yes, Billy isn't picky. That's right. Thank you. Okay. Any other? Yeah. Well, we're not saying that Billy ate all of the greasy chicken for lunch, right? So the clue is the sum. You're saying there exists at least something such that it's greasy in his chicken and Bill ate it for lunch. We're certainly not saying that for everything in the universe such that it's greasy chicken, Bill ate it for lunch. That would be extremely unfortunate for Billy. He would die. We're making a much more sensible claim that there is more than nothing such that this is what he ate for lunch. Does that make sense? Because, again, I think the topic of that is the greasy chicken, really. Okay, let's try to squeeze in one more, and then we'll call it a day. Oh, man. All right, let's do this one. Once again, I've failed to use only names for this, but let's roll with it. Assuming that Tom stays home Not all of the work will get done unless at least 2 of Jim, Dia, and Sam show up. Okay. We can do this, though. We can do this. The trick is just to take it one part at a time. So, assuming that's a conditional, right? That's an if-then. So we say, if this thing, then this thing, right? So, Tom stays home. If ET, then this all thing. So not all of the work. Not all just says, or sorry, it's a disjunction. So this thing is a disjunction now. So we've got something or something else. Not all of the work will get done. It's not the case that for all x, if it's work, then it will be done. Or at least 2 of Jim, Dia, and Sam show up. At least 2 of. So how do we do at least 2? I think we didn't review that today. Well, we can just enumerate the cases. Like literally, if you've utterly forgotten how to do this, you can just enumerate the cases. So shows up. So HT and HJ, or HJ and HS, or HT and HD. Right, that's at least 2. Yep. Sorry, it should be, oh yeah, I did HD and HJ twice, sorry. Yeah, HD and HS. Yeah, sorry. Sorry, you gotta speak a little bit louder.
It should be HD and not HD.
Oh, HD. Yes, because Tom all along. Oh. Oh boy. Okay. Is that, we got it now? Okay, okay. Yeah. Okay, so this is an informal notation because we've got a series of disjunctions, but that's okay. Informal notation's all right. Okay, any questions about this? Yeah? How about they all show up? That's okay. So at least 2 showing up just requires 2 of them. If they all show up, then this one is true, and this one is true, and this one is true. And that makes this whole thing true. Is that okay? Okay, let's call it a day. We'll see you for the test on Monday.